was very interesting for me when we were doing our coordination call was, the difference between malicious behavior and fraud. I think that's also
Yeah.
interesting to talk about.
And also like
And
anomalies that are not fraud or are not malicious, but would be flagged maybe by an algorithm.
Yeah, that's a false alarm.
Yeah.
all right, so we've been live for 20 seconds now. Hi,
All right.
everybody. Thanks for joining us. Hopefully, this was yet another random start. Somebody actually gave me feedback a few days ago saying that the beginning of the videos are very random. And it was like, yes, mission accomplished.
Yeah.
Thanks for joining me today, Serena
Yep.
and Carrier. It's very exciting to have you. You all are familiar with Serena, but Shariar, why don't you tell us a little about yourself, like a quick intro?
Sure. So, as you mentioned, I'm Shahryar. I'm a lead data scientist at Manulife. I'm leading NLP and R&D team over here. And in the past, I've worked for the fraud team at Manulife and in the cybersecurity teams at TELUS and Defense Canada. So I have also got a PhD in computer science from the University of Western Ontario. That's kind of summary for myself.
Excellent. Serena, what's new with you?
Not too much. I'm wearing my computer glasses today. People might notice that I don't normally wear glasses. Helps protect your eyes if you have like a blue light filter in your glasses. Other than that, I'm drinking. It's something new. Usually I drink water. This is a matcha cocoa mix. I got it for free. As some of you know, I do some content creation around veganism as part of building a community for my app Food Shake. So I was given some of this cocoa matcha powder for free through social media, which is pretty cool. And yeah, it's supposed to elevate your mood.
Does it?
I'm like, my mood's elevated just by doing this.
Sounds so. You're one of those influencers now who get
I guess so.
free stuff.
I know, it's pretty crazy. Yeah, there's a lot of money in that space. It's wild.
So, Amir, you mentioned the talks are starting randomly, but I think you need to set the next goal, stretch level. Just deeply random talks. They need to start deep.
Yeah.
True. We should start from a very deep conversation at the very beginning.
Right.
Awesome. So today we are going to talk about fraud detection. I don't think there is any week that goes by where we don't hear about yet another cyber attack or leakage in the blockchain, hacks in the blockchain space, etc. And it's definitely a very interesting topic. Much broader topic of machine learning for cybersecurity and threat detection. That, by the way, we should bring some people to talk about that. But today, we wanted to talk about detection of malicious behavior in general, which is something that I learned a few days ago from Shariar, because I always thought, anomaly detection is what we're doing. But, that's definitely a more nuanced space, as we always come to conclude in deep random talks. So, maybe I'll pass it to Serena, and we can get us started on the topic.
Yeah. So I agree with what you said. I also used to think that fraud detection equals anomaly detection. I guess like level setting a bit. When I first started exploring machine learning, I would always see fraud detection. This is a great application of machine learning. And I was always like, what is fraud? So I looked up a definition for fraud, and I would define it as it's the deliberate act of using deception and false representation for unlawful gain. And yeah, like technically speaking, I would say that fraud detection is a type of anomaly detection. And then anomaly detection is the process of identifying data points that are unusual or deviate from a data set's normal behavior. Sometimes anomaly isn't fraud, though. But I'm not sure if I'm maybe missing something with my definition.
No, I think you're right. But anomaly detection just means detecting any kind of anomalies in your data. They may not be fraud, and then you have to figure out what is the fraud over there. So they may not. And then it's not just anomaly detection that we can use for fraud detection. We can also use supervised machine learning for fraud detection, or graph analytics for fraud detection. So it's like a specific type of behavior that we are detecting that can be detected by any of these methods.
So it sounds like in this case, anomaly detection refers to the class of algorithm, like supervised learning is a sort of class on its own.
That's right.
Okay.
So anomaly detection is a class of algorithms which where you have to, you know, you have only very limited kind of data. So you only have the normal data. You don't have anomalous data at all. So that will be called unsupervised anomaly detection. And you have to train specific type of algorithms, or tune the common algorithms in a specific way that they can be worked over here. Because usually in supervised learning you have two classes, which is straightforward. You have to predict those classes, but in anomaly detection you don't have two classes really. So that's, I know, like you just have one class and you have to find out what is deviating from that normal behavior. Sometimes in anomaly detection you do have a little bit of information about anomalous class. uh, so a lot of information about normal class, but little bit of information. So that's kind of semi-supervised. So you cannot really train a machine learning, supervised machine learning algorithm over here, because the data, let's say there's only 1% data about anomalous class. So supervised machine learning needs some sort of balancing, right? So here you have to then use the normal data to train your model, then find out the threshold using those anomalous classes that you already have. So then it will be semi-supervised learning. So, so that's how we can classify anomaly detection.
And is there? I also have heard another term, fraud recognition. Is fraud recognition different than fraud detection?
Fraud recognition different than fraud detection? That could be a question for our audience actually, if they have recognized anything like that. Because in like whatever I have experienced, like fraud detection and recognition probably are the same thing.
Yeah, I have a slightly different take on it because there's this paper that I happen to be the first author on, first called Cyberbird, and Cyberbird is around, or it focuses on anomaly recognition. And I spent a lot of time trying to figure out what is actually, like, why is this data set called an anomaly? Like, it's applied to anomaly recognition problems. Anomaly detection is, yeah, determining the presence of an anomaly or fraud recognition is classifying that fraud, or I guess classifying that anomaly as a fraud and then classifying that fraud to some specific kind of fraud. So it's very nuanced. I would say that anomaly detection in itself is the more interesting algorithm, in my opinion. Anomaly recognition is more like a classification exercise.
Yeah, so one problem with anomaly detection is that, any kind of algorithm, whether it is a deep learning algorithm or is a non-deep learning algorithm, you end up generating lots of false alarms, because the algorithms are detecting correctly anomalies, but they may not be the something that you are looking for. In this case, we are looking for fraud. So you have to add some additional sort of classification on top of that, or rules that can, or some sort of filters. So this is how should fraud be determined. Okay, so like in terms of I can give some examples for fraud detection as well. For example, in banks there's a lot of fraud. uh, like Personally, I have got a chance to look into this problem, and then I was just shocked, like how much fraud banks are encountering every day. And like, hundreds of bots accounts get created, and maybe humans are creating them as well. But then they are trying to deposit fake checks. They are trying to steal money from another credit card, and so on. So there's a lot of fraud on the bank side. There are examples for forged identities or forged identity documents. Nowadays, it's very easy to just fake your identity and create a new one. So there are actually right now vendors which can just help you in detecting those forged documents. So using deep learning. So that's another example for fraud detection. Deepfake, I am sure all of you have heard about that. So deepfake is actually helping in generating fraud. So we have to detect those frauds. So that's another example for the fraud detection. Fake product reviews could be another example. So a lot of people, can type fake product reviews or to promote their product. So that is another example. Sure. So, Amir, do you? Yeah.
Usually when I think about fraud, I think about finance for some reason, but you just mentioned product reviews, and that is an example of fraud, and I just haven't really thought about it that way. That's interesting. And
Yes.
some other examples of fraud that I've come across, because I spent some time thinking about it with regards to my work at Shopify, since I do work in the financial part of the company. There's this term called card caching. I'm not sure if you had mentioned that already, Sharia, if I spaced out or anything. But so card caching, it's CASHING. I thought it was cache, like caching data, up until yesterday. But no, it's caching. So it's like, let's say that I own a store like Serena's Socks. I like to sell socks. I could steal Shahryar's credit card, and then I could buy
Why not
products.
Amir's credit card?
Well, I mean, I have to choose an easy target.
Okay.
Just kidding. Amir is out of the country, and I think you are in Canada, Shahryar. So
Okay.
there we go.
You're safe.
Yeah, so I could steal your credit card, and then I could buy products at my own store using your credit card. And I believe that's called card caching, because then, Shahryar, you'll be like, hey, bank, there's these transactions that I didn't make. And then the bank will pay you back for that, and then I get to keep the money. So that's another example of fraud. And then there's also, like cases where maybe I have my own store and someone like a fraudster, maybe Amir's the fraudster, Amir will like learn my credentials somehow and then take over my account and then transfer payments from my account to his account. That's another type of fraud. And then there's also like money laundering. And then there's also the fraud where you get an email from someone saying they are a princess and they need you to send them like $1 million. So there's a lot of different kinds of fraud, but all of those examples and like everything I can think of are all around finance.
So there is another non-finance example, and all of you have encountered it, and you are all encountering it daily. Fake news and fake news on social media, and WhatsApp, Facebook, anywhere you go, you will find those fake news, right? And like how much noise got created in US in the last election because of that. So that is a very good example. And every day I receive lots of fake messages on WhatsApp. So I think we definitely need a fraud detection on that side as well.
Yeah, for sure. I think that problem is going to get worse before getting better with all, the GP3 based marketing and product description products that are popping up. I'm sure they mean well, but I can see very easily how they can be used for malicious purposes. I think a lot of the examples that you gave focus on an external agent trying to sabotage things, but of course, there could also be internal agents trying to, leverage the accesses and privileges they have for some benefits. Like, I don't know, you might be a person working on the floor of a capital markets department in a bank, financial institute, and you want to have, essentially internal information about what is going to change and how you should, buy or sell stocks, etc., and share it with others that are in your circle, etc. So definitely a lot of interesting things that have to be that we can look at. But let's talk about how, because essentially what we're talking about, like regardless of what technique we're using, it's looking for essentially a needle in haystack. There are a lot of activities going on, probably very, very large event data sets that is involved in things like this. And we want to look at anomalies. And an anomaly is something that is different than the normal variations. So, the system, whatever event we are tracking, has a bunch of variations that is, market, system log, etc. Things are changing all the time, but you want to find what is changing more than that, right? So that sounds like a very hard problem. So what are some of the basic ways that you can even get started to explore this problem?
The most common way for fraud detection in the financial sector is rules. So you go and talk to your specific business unit. They will tell you all the rules that they use to detect fraud, and maybe they would be suffering to because of the lot of fraud or lot of data, they would be suffering to automate that, so they can easily help them and implement those rules. But even the rules have the problem, they can generate lots of false alarms, so they need a lot of tuning, so they have just like anomaly detection. In the case of so that's like something that you can easily start with, and achieve your business value, and your organization will be happy as well. Sometimes it depends on the kind of business unit you are working with. You can end up saving millions in few days, or you can end up saving few hundred every day, so it depends on the unit.
And with the
uh,
rule-based system, let's say that I wanted to like make a startup and I am creating a new financial institution or something. I have no idea about fraud or risk or anything. Would I have to hire somebody who's specialized or like certified with regards to risk to
yeah.
come up with those heuristics?
Yeah, so rule-based systems are kind of like expert systems in early expert systems. So you need a domain expert to define those rules. Somebody who has already worked in that area. So you have to interview them, kind of like human-centered design. So you have to meet with the domain experts, see what they are doing, and then implement them. They might be using some tools which already have rules, but there are lots of things that they are suffering from, like they are not implemented. So identify that research gap, and you can easily launch your startup. Maybe Amir, you can have a new branch in your company. So that's one thing. Another thing is, like you asked about, or what about first party fraud? That's very difficult to detect, because rule based system or simple anomaly detection won't be able to detect first party fraud. So let's say uh, there's somebody who has a retirement account, and in retirement accounts usually there are millions of dollars. So wife or kid or someone else who is personal to that person, he can just steal all the information. So he would be then logging in from the same IP address. He would be using the same username, password, same device. What can you do? Like the rules-based system won't really work in this case. So what we can do, actually, we then have to customize, build models for each of the accounts or each of the users. Like, what is their regular behavior in the past? So, for example, they have been paying bills, and after paying bill, they withdraw $500, or in the range of $100 to $200. So we can get those kind of sequences that, and can learn that kind of a behavior, and then we can identify uh, that there is something wrong going on through anomaly detection or supervised learning, something like that.
That's interesting about, yeah, how you said you would build a specific model for each, I guess, client. Um, I've heard that that can be very unscalable. And whenever I've never actually worked on problems where I have built a specific model for one specific person. I've always tried to do some sort of clustering or cohorting.
Yes.
Does that scale?
Yeah, so that's a good thing. And usually, data scientists, when they are dealing with this problem, they don't go for individual models, because scaling is very hard. If you have 1 million users, you will end up creating 1 million models, right? So even if you are not creating models every day, let's say you create once a month or once update once every week. So there is still, it is not easily scalable. So what we can do, we can use Spark for scalability. So we can, for example, simple machine learning. Like there is a lot of machine learning code available on Python, so that is not scalable. So you can wrap it inside Spark's user-defined functions. So I'm sorry, I'm getting a little bit technical. So you can wrap it inside user-defined functions of Spark, and then train them on each user in parallel on thousands or millions of users. So that's something you can do.
Yeah. So the scalability is definitely an interesting question, and sort of where I was going with bringing up that there is a lot of data involved usually, and you're looking for very small signals in that. And I assume the rule-based systems, other than the fact that that was the thing that people had prior to, more statistical methods, uh, has the very important advantage of being very scalable, right? Like you have a bunch of rules, you just apply it to everything, and you get something, right? And I assume that is still captures a big chunk of the cases, right? Like
That's
if
right.
somebody literally, steals a credit card and goes to a different country and use it, that's a very clear, indication. So, is it the case that when we're building these systems to tackle scalability, we, use basic methods to a big chunk of the data and then go to more advanced method to capture more nuanced cases? Because I don't think you would want to run everything through a very heavyweight deep learning
That's right.
model.
That's right.
Okay.
So this is usually the approach. You combine all of these. So you can combine all of these in one application, or usually what happens is that in commercial organizations, they have multiple applications for fraud detection. So there is an application that is a rule-based application. Most vendors sell that application because first it's easier to sell. Everyone understands what it is doing. If you sell a machine learning application, it's difficult to convince everyone. So they have lots of such applications, so they will be using it, and then machine learning will cover the gap that is not covered by the rule-based application. And then similarly, we can add the graph-based learning as well. Usually graph is not covered by traditional vendors, so that is also an interesting approach to solve the problem.
Yeah, so how can graphs be used for fraud detection? When we had our quick coordination call about this, Sharia, you brought up graph methods. I said, I remember I said, I think it's very exciting to talk about graph neural networks and fraud detection. You said, hold on, we're not talking about graph neural networks, we're just talking about graphs. So yeah, I guess like how can graphs be used? But maybe first of all, what is a case of fraud where a graph is helpful?
Okay, so yeah, so in the case of, first we need to understand, a problem. So if you, let's say there are bank accounts, and there are lots of bank accounts, and there are some fraudster who created online bank accounts in a bank, and those fraudsters have stolen credit card from somewhere, or they have stolen as a credit card. And what they will do, they will try to create those bank accounts with that same kind of a credit card, right? So it is possible they may not use the same credit card. They will use a credit card in one account. In a second one, they might just use regular credentials, phone, email, something has. In the third one, they might use a credit card. So they would create a network, a ring of fraud like this. So it's very straightforward to detect this kind of a fraud ring using a graph algorithm. So first we need to convert this data into a graph data structure. So let's say each account can be a node in a graph, and then each of these attributes like email, phone, a credit card, they can be attributes of the nodes, or it can be heterogeneous graph where each of the nodes can be represented by email, phone, and the account. And then we just need to find out the connections between these accounts. And it has been very successful actually in detecting fraud rings. Very famous algorithm is connected component algorithm, which is very famous in the data structure. So that can be used to just find out what are the fraud rings. Sometimes there could be, when you search for these communities, you can find out regular accounts as well, which are connected. Maybe there are joint accounts, but that can be easily investigated by the fraud team. So, Amir, do you do anything in the case of the area for graph?
I love that you brought up the connected graph components, just because when I have been studying data structures, I was always like, why do I have to learn these algorithms? But I feel a little bit more, I guess, not motivated to go study more, but like happy that I've learned that anyways.
Yes, it is like what Shahriar was saying was interesting, because the first time that I started, I heard about use of graph in cybersecurity. That was a very similar scenario where of course hackers are getting more and more sophisticated. So when a hacker gets into a system, they're not going to immediately steal stuff, right? Like they're going to plan a bunch of backdoors for much more complex attacks, and cover their trails. So it is very difficult to use rule-based systems or use systems that just keep track of the behavior of the user, unless you start connecting literally the dots about this person came in, did this thing, and then they changed their identity, and then this did this other thing, but I can see that the device was the same. Like there are a lot of moving parts, and it's very difficult for the traditional machine learning methods to keep track of all of these changing parameters. And I have not heard of this technique. What did you call it? Connected
Components.
Connected components.
It's a famous algorithm
Okay.
to just find out, communities inside a graph.
Okay, so it is just a community detection kind of
It's a
algorithm.
community detection algorithm, that's right.
I see. So what's the idea there? Like, how does it detect anomalous behavior?
So it just finds out the connection between different nodes of the graph. So let's say there is a common credit card between two bank account, and each account is representing a node. So there will be a connection, right? Then there could be a third account connected, like this second account could be connected to the third one through a phone number. So there is a connection over there, and then it could be connected to another account through email address. So you can find out all those. As if, and let's say if credit card is suspicious, so there is a straightforward indicator, like all of these accounts are suspicious and they are connected. So there's a fraud ring. There are also other algorithms in graph that we can use, and of course we can use graph neural network as well. We'll discuss that later.
Yeah, so it sounds like, so when I was getting all excited about graphs, and graph neural networks applied to fraud, I think the reason I thought about graph neural networks right away is because I don't quite understand fraud and what fraud looks like enough to know why graphs would be useful. But just to reiterate what you're saying, so it seems like in banking, every account, if you represent it as a graph, should be like a unique entity on its own, right? But if there's fraud, then there will be connected components. So if you use like an algorithm to determine the number of connected components, like if you have connected components, then you can say this is suspicious, like this shouldn't be happening. Okay,
yes,
that makes sense.
That's right. So, but of course, there is a chance for false positive here as well. As I mentioned, some accounts can be legally connected because they are joint accounts or things like that. So that has to be investigated.
So is that what we call entity resolution? Like you're trying to figure out which entities are the same?
So this is community detection, what I just explained. Okay. Entity resolution is similar. Like the problem is little different. So in entity resolution, suppose there are two insurance agents. They are trying to sell policies. So there is one insurance agent actually is selling policies, and that agent just sells policies to himself or herself, and they shouldn't be doing it, and or maybe selling the same policy to many different users and earning the premium from them and just giving one amount to the organization, and then the organization has to pay for all of them. Eventually there is just faking some sort of information over there. So what that person is doing is that he created, let's say if he sells it to himself, he created a different account with a different sort of variation. So let's say it's called John Smith, the next one is John H. Smith or J. Smith, something like that. So there are some variations. You cannot really just search and names and find out what are the by using fuzzy logic, what are the common variations of that name, because there could be legal variations as well, right? Some there could be duplicate names from the legal people. So in case of entity resolution, the problem is that how we can find out the connections between these like these kind of agents or these kinds of accounts in the company or company's database. So we can we can use an algorithm called similarity matching, node similarity matching, and what it can does, it can just find out again in the same way, just like the bank case, what are the common attributes between the two nodes. So let's say there is an address which is common, there is a phone number which is common, so there is a node similarity between two of them, and then it will give you the distance value. Then you will have to figure out what should be the threshold on which we are on which we can detect fraud. So this is where you need a data scientist to find out a threshold. Otherwise, everyone can apply algorithms. So that's something we can use. Connected components can also solve this problem for entity resolution. But at the conceptual level, they are different problems. They could be solved by similar algorithms. And I want to connect to graph neural networks over here. So let's say you have these names that, like, let's say addresses, phone numbers, and names. They're not exactly matching. If they are exactly matching, you can have an edge between them. So there is no connection, right? So, but there is a fuzzy matching that you can do. Let's say address, some part of the address matches. So you can say that, there is a connection between two nodes. So if you do that kind of fuzzy matching between different nodes, you can end up with a lot of links. Then it will increase the dimension of the problem, and it will actually explode, and it will take a lot of time. So here we can use like node embeddings, and we can embed each of the node into a vector space, reduce the dimension, and then find out the similarity. So this will then become a link prediction problem. And of course, we can use node embedding, or we can just directly train a graph neural network to predict this.
So if you're looking at like using a fuzzy matching algorithm to match different names, let's say, I'm imagining that you could come up with several different graphs using different thresholds for that matching algorithm. And then similarly, if you have like embeddings, you could, I guess, like have different measures of similarity and all of that. So in practice, I would guess that you do that as part of the research process to try to define that threshold.
That's right.
Right?
So that's right. We have to, as I mentioned, if we have some sort of data points about anomalous data, then it becomes a semi-supervised problem. So we can use that to find out what is the right threshold where we get, fewer false alarms, as few as possible. There will always be false alarms, so as few as possible, but we cover as many as possible the true cases. So we can use that. Or if we don't have that information, then we have to start with some sort of a threshold and see, and then we have to do some sort of trial and error experiments with actual users, which threshold is working best. So it could be like A/B testing, something like that.
Whenever I hear threshold, the first thing that comes to my mind is, what is a downstream task? Speaking of downstream tasks, there's a good there's a good question in the chat by Justin, who's asking, we gave a bunch of examples what we're calling fraudulent, I guess, anomalous behavior and fraudulent. Like we made a difference between those two. Like anomalous behavior is just, you don't look like everybody else when you're doing this thing, right? Versus fraudulent. And they're asking, given that everybody's faking everything, what's the boundary? Like we kind of smudged that boundary at the beginning, right? So, and I think that's very related to the use case, aka the impact of that anomalous behavior. Like if you are just faking, some food, and you're saying that this is vegan because that looks cool with your friends.
Are you directing towards vegan app?
No, this is product placement. Siri, no, wait away.
Check out foodshakeapp.com.
Like if that doesn't have, an impact on anything beyond, just a very small group of people liking each other's image on Instagram, versus, your behavior is, $60 million hack on, some Bitcoin chain, blockchain, thing. So those are very, very different stories. Like, I guess the question is, what are we talking about? Are we talking about, when we say fraud, is that person with the fake vegan dish a fraudulent person? Is that a fraudulent behavior? Are we talking about that or not? And I'm want to circle back a little, and it sounds like a lot of examples that we brought up had a financial component in them. I think it is more than that. Like I think the examples that we gave had a bit of power dynamic situation when you wanted to have access. I think that also eventually gets to the financial gain. But is there a more strict definition? of what we're calling fraudulent based on the use cases and scenarios they're happening in?
So basically, if you Google fraud, definition for fraud detection, it will connect it with the financial advantage, right? So fraudster is trying to gain financial advantage through false means. So that's the definition for fraud detection. So what we did in today's talk, we expanded this scope to fake news detection, fake product detection, because by using, by propagating fake news, person is not getting financial advantage, but they are getting some other advantages, right? So they are using that to propagate their own agenda, or do something else that will change the behavior of the people. So that's not a non-financial case. But usually in the case of fraud detection, it's about like financial means, like taking advantage of something and through like false means, and that is and achieving the financial value at the end. You asked about if everyone is faking, so that's a good thing. Everyone doesn't fake. Most people are good people in the world. So yes, so we are in a good society. So most of us are follow the rules, right? We are very afraid to not follow the rules, and we are good guys. And there are only a small number of people who do not follow the rules. They just like, usually there was a study by an RCMP attended a conference. So fraudster or the cyber attackers, they are not really the programmers or software engineers. All the programmers or software engineers, they might have developed those bots. They would sell that in a black market or the dark web. But the criminals, people who have the criminals background, they start using it. And when they arrest them, these are those people, they have done some sort of criminal activities in the past. So there are like very few people that, or very few, like fraud is always smaller than the actual actual data. So that's what we want to detect. And if it is a lot, then the straightforward thing a company would do is will just stop that thing, right? For example, it will stop the online bank account creation, or it will stop everyone from writing product reviews. So there will be no fraud at all. If 90% of the people are doing fraud, then there is no advantage of for marketing that product, because it's always resulting in fraud. We are marketing a product because it is not resulting in fraud, generating a lot of revenue. So that's why the companies are adding a fraud detection method, so that the revenue remains there. They don't lose much on the fraud side.
Yeah, it's really interesting, this definition of fraud and all these different examples. I think I'm going to guess whoever came up with the definition of fraud, it was many years ago before social media. Because with this blossoming creator economy, it's fascinating. Like I said at the beginning, there's a lot of money in social media. So, like, let's say if I was to use a deep fake and make myself and all of my photos look like I'm 6'1" instead of like 5' something, maybe I would, like typically people who are tall are viewed as like more attractive, blah, 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 especially on social media. I could gain a following of millions and monetize that and charge brands like $10,000 a post. And I would say that is fraudulent because it's, it's deceptive. There is financial gain, but that sort of financial gain wouldn't have been possible even like 10 years ago. So then going back to the question that Justin asked in the chat, the question was like, how would you define if something is fraudulent or not? Like if somebody staged their photos and said they're like airplanes in their photos. I think in that case, you could train a model that's like, like a basic computer vision classification model, like real photo versus faked deep fake photo. But I think as time goes on, it's going to become even more difficult to have these models that can determine what is fake and what is not, because the technology is really improving to an incredible level.
That's right. Whenever this is classic data science problem, right? Whenever you have enough level data, you don't need to go for anomaly detection or threshold based methods, because they will end up in false alarm. So you have to tune that at the end. So you should focus on the classification, and there are lots of, I think we have shared in the resources, like lots of papers on how people are using deep learning or classification models for detection of fraud. So deepfakes is definitely an example for classification. For product reviews, I would say this is a good example for classification. We can find good samples for fake products, right? Product reviews. So it is easier to train a classifier over there. And the advantage of training a classifier is that it is much more accurate than threshold-based methods, whether it's rule or the graph or anomaly detection methods.
So I want to steer. Okay, I'm going off script. Well, we don't have a script for these conversation, but didn't discuss previously. But it occurs to me that we are talking about fraud generally as anomaly detection, but we are going to a world where GPT-3 is writing product descriptions, and DALL-E 2 is creating marketing graphics.
Yeah.
So I can imagine 5 years from now, these things that we're calling fake will be just the de facto ways that we describe things on the internet, and we write reports and create graphics to describe things, etc. So what's the boundary? Like, how are we going to define that this is bad versus this is good? Because just the fact that something is fake, well, I mean, quote unquote fake, is not going to be enough anymore, right? So I think there will be extra layers of explainability that is necessary to be provided to somehow, add more layers of how we can in a way that is, I guess, safer, more responsible, etc. Is that the right way to think about it?
Yeah, you are right, actually.
I'm going to just go back to social media again, because I've seen so much of people being fake, trying to gain for financial gain, all that stuff. And as you were saying, Amir, there needs to be, disclosure around this. So if a product review was generated using GPT-3, I think there should be some sort of disclosure saying this product review was generated with GPT-3, similarly DALL-E 2. I think as long as people know that what they're interacting with is generated by some technology rather than written by hand or drawn by hand, then that's okay. But yeah.
Yeah, I would add, over here, we have to, just like for the traditional definition, there was a financial advantage, right? So whenever there is a financial advantage, this is a fraud. This is not just an anomaly. This is not just something irregular the person was doing, something new. For example, in the case of COVID, when the COVID-19 came, everyone went online. So they started using their financial accounts in an online manner. So it was an anomaly. This was something new. But are they taking financial advantage over there? So that was a definition. So in the case like of a broader definition, it would be, are they affecting the society? Like generating text from GPT-3 or BERT or anything else would be fine, as long as it is not negatively impacting the society, or as long as students are not generating their assignments through it. So then every university has that option to submit the assignments to automatically evaluate. So they will have to add those things to evaluate it. But where is the boundaries here? What is the impact? Is it impacting negatively? Then if it is impacting negatively, then it is a fraud, right? Even your data is being stolen, or we can say like it is being used by the top companies every day, right? So how is it used, right? So everyone was happy as long as they were not impacted directly. Now people are not happy when they learn that it is in fact impacting us negatively.
So I'm going to go more nuanced on this topic, right? So cases of financial advantage are very straightforward. Like, I either stole money or not. Like, I walked into a bank, opened their safe, took the money and left, right? That's black and white, like that happened or not. But a lot of the cases of advantage that we're talking about now are way more nuanced, like the case that Serena was saying. I could be doing something that is just a slightly gray zone, gray area for a year, collect a lot of followers, and eventually turn that follower into financial gain or other types of advantage, right? So I think the problem is that as we said with cyber attacks, like that's exactly what they do. Like they never go in and steal something and leave, right? They go in, plant a bunch of backdoor code, and then do a bunch of other activities, and eventually build up towards what they're going for. So the use cases are getting a lot more complex. They're getting a lot more graphical. right? And going back to where the conversation was, I think both the methods that we're using to detect malicious behavior, I don't think we should call it anomalous behavior anymore, but malicious behavior, right? Because it might be a very commonplace thing like fake in product review or graphics. It's just the malicious behavior could be much more complex, and that's exactly where the future of all of this, I think, is going to be very graphical, because the behaviors are very, very non-linear and branchy and like literally graphical.
You just created a neural network there. So do you do any work related to fraud detection or graph or at aggregate intellect?
We do not yet, but I assume at some point we will. We like the question, like the reason that I brought up the follow-up I just did is that the question of how your behavior today is going to impact somebody in the future is a very interesting question for us, right? Because on our platform, what we are creating is this knowledge repository where actions of people, well, it is the positive example of what we've been talking about. Like a bunch of people are doing activities and their activities is contributing to a knowledge base, and then and it is not a linear, straightforward interaction. Like it's not like somebody came in and did an activity that somebody else gained the value from it, and then there is a transaction of money. Like a lot of interactions happen until some money materializes. Like for example, like we are doing this session, we are curating some knowledge, right? Like we are telling people about how fraud detection happens and what are some of the nuances about it, and then somebody else might come in and create another recipe using this information and some information they have and add to it for a slightly different use case, and then somebody else builds on that, etc., etc. So how does this knowledge propagate in this network that we have and eventually gets to value that becomes financial at some point, is a very interesting question. And of course, given that it's complex, when we are big enough, fraud will exist in it. But until then, the dynamics of knowledge propagation in this network is very interesting. And I think understanding that very well is a very fundamental part, is a very fundamental component of making sure that we also can detect malicious behaviors, like somebody who's trying to manipulate the system. And that goes back to the whole graph neural nets, right? Because if you have good entity resolution, if you can figure out who's where and what they're doing and what they are, in terms of persons, in terms of artifacts of various sorts, like bank accounts, or in our case, resources, really getting really good embeddings, I think, is the name of the game in all the above, right? If you have embeddings that capture nuances, you can do a lot of interesting things.
That's right. Embedding that will capture the similarity, not the nuances.
Okay, interesting. Tell me more.
Because embeddings are trained in a way that they will capture the similarity between the nodes, right? And then you have to find out which nodes are similar, and then figure out what is really clustering together, and is it a nuance or not. So nobody has created embedding in a way so far that can capture nuances. Whatever literature you can look at is always like similarities, right? And then they find out an embedding, and that's what they are focusing on. I think that would be a good idea for research if any researcher is listening.
How would you even represent that? Because when I think of embeddings, I'm like, okay, you can embed different representations into embedding space, and then it's perfect to look at similarity because you look at like the distance. What would that even look like, adding on the nuance?
To need to define a good cost function. How?
Yeah.
And will it be a deep random walk or like shallow or random walk? That we have to think of.
So there is an example for that. Well, we are going completely random right now, but in hashing, most of the time you're trying to hash in a way that similar things map to similar things, similar hashes, right? But sometimes that's not what you want to do. Sometimes what you want to do is to hash things the things that are drastically different if they have a small difference that you care about, like locally sensitive hashing is an example of that, right? So you're trying to match things that are slightly different to things that are drastically different. And that's sort of what I was. Of course, I understand that most of the embeddings that we do today is similarity based, like it is largely with cost functions that are around detecting neighborhoods and such.
Yeah.
But I think embeddings will get, and probably getting embeddings that are longer and longer to capture more details is one way to do that. I don't know, but that's definitely. Maybe somebody in the audience knows the answer and can guide us.
Please tell us.
Tell us the cost function.
Right.
But yeah, going back to graphs, I am thinking about, like what you said, Amir, about aggregate intellect. There's no fraud on the platform yet. I guess once there is fraud, then you've made it.
Maybe Amir is so nice, he doesn't think it's a fraud. So we need to define the definition of fraud.
Yeah, exactly.
What the question he asked, he is not sure about that. You have to add that.
Yeah. I guess I'm thinking, like, at what point will you need to start thinking about fraud? That's the first question. But actually, what I really want to ask is, at what point is it useful to start representing your data as a graph, perhaps for the purpose of fraud detection? Because this might just be an assumption. I think most of us, when we start out on our data science journeys or in any sort of data career, we first work with tabular data, and graph data structures or kind of feel like a bit special or more exciting, less standard. So yeah, I guess to wrap up that question, like, at what point should we start thinking about graphs in an early application?
I think that goes back to the scalability. So, essentially, in a lot of use cases, in a lot of scenarios, it all depends on how much data are we talking about and how well can you as a team deal with it, right? Like if there's fraudulent behavior, but you're getting one event per day, of course you can just take a bath and go deal with it, right? So, and you can do that based on your gut feeling. When it gets to a certain number of events per hour, etc., then you probably want to have rule-based systems. And then as it gets more nuanced and you're dealing with a larger amount of data, and the attacks become more complex because in early versions of the product, the attacks are simpler things. But when you become more important, and more important hackers are or fraudulent fraudsters are targeting you, then you probably want to start going to more complex scenarios, and that gets into the whole question of scalability. I think doing things that are scalable for the stage that you are.
Yeah, I think I would like to disagree a little bit over here. So we don't have to wait till the data set becomes really large to implement the graph. So when you have reasonable data, you can start looking into the relationships using graph as well, right? So you just have to identify what should be the node and what should be the properties or the features of the nodes and how they will be connected. So that can help you in visualizing a lot of things. It's not just about fraud. You can also find many other patterns, how people are behaving. For marketing, people use graphs as well, right? So to connect, like this user is connected to that one, this person buys this and another one buys this, so there is a connection. So there it is. It can be useful to start early with the graph. That's what I learned. I didn't start with graph earlier, but I think starting with graph earlier is helpful. It can help in solving issues. I mean, if you do not want to create a graph, you can also create graph features and use in your machine learning algorithms. So find out common names, common emails, count of that, and use that as features. So that can be something.
Definitely. We are very close to the end of the hour, so I'm gonna quickly show something on the screen. A lot of can you see my screen?
Mm-hmm.
Is it still loading?
It seems like it's loading.
Oh no. Okay, try attempt 2. How about now?
Yeah,
we can see it.
Now. Okay, great. So what I'm showing on the screen is essentially the research that the three of us, well, mostly the two of them, did to collect resources and write notes about the topic that we're talking about. The link to this is in the video description, so check that out. You can see, this video as well as a lot of notes that, Shahryar wrote all of these, and a lot of other resources that he suggested, as well as a lot of resources that Serena found and wrote notes about them. So definitely check that out. Is there any of these resources that you, Serena, and Shahryar want to highlight that if people only look at one item, they should definitely check that one out?
I think it will depend on the use case, what people want to look at. So if they just want to start with the tools, so there is a section on the tools. PyOD is a very good library. We have lots of anomaly detection algorithms. They can start over there. If they are into NLP and images and looking to identify fraud over there, so I think it would be good to look at the resources on GANs and the BERT.
I would suggest the Towards Data Science article titled Fraud Detection with Graph Analytics. Even just reading like the first third of that article is pretty useful because it gives an example, like quite a concrete example of when graphs can be used to detect fraud. I did not think about fraud in this way until this discussion. So fraud is not just, now I'm thinking of fraud as not just anomaly detection, and fraud can also extend to any malicious behavior. So my call to action to the audience would be to think about different examples of malicious behavior and perhaps what algorithms you could use beyond standard anomaly detection algorithms. What could you use to solve for these problems? What about you, Amir?
Yeah, I definitely learned quite a bit from both of you today. Definitely changed how I was thinking about a problem. So like many other things, I think the boundaries of how we were thinking about fraud previously and how we should think about it is changing, and we have to adapt to it. And definitely more advanced techniques that don't have to be neural network based. They can be just graph based. Well, and even as Shahryar said, just literally visualizing what is happening in your system can give you a lot of information about what's happening and how you have to adapt to it. So definitely my call to action is check out the resources on the recipe. And if you know anything more about any of the topics we talked about and we missed it, you can always leave a comment or suggest a resource to add so that others can use. Thank you so much again for joining me today, Serena and Shahryar, and hope to see you, audience, next time, where we are going to talk about machine learning, building machine learning communities. It should be a very fun conversation. See you all next time.
Thank you. Bye.